Okay, well this is example 2. It's actually one way to prove the base angles theorem. Okay, one of the things that they told us was they said that this was the median. And if we forgot what a median was, a median goes from the midpoint of a side to the opposite vertex. So for any triangle, the median goes from the opposite vertex, in this case it's A, to the midpoint, M here. Okay? So that's one thing that we noticed there. That's where you get your median here. Okay, so I'm going to erase that stuff out. And I'm going to redraw it in there. We know it's a median. Okay? So we're going to, if we got there. And what we want to do is we know this is an isosceles triangle. So AC is congruent to AB. That's given to us. They want us to show that this angle, angle B, is congruent to angle C. That's what they want us to show, because then we're actually showing that the base angles are congruent. So we're going to have to use congruent triangles here, and I'm going to do a 2-column side-by-side proof here. So let's start with that here. And we know that it was given to us that AC is congruent to AB because it's an isosceles triangle. And that was given to us. Okay, so what we're going to do now is, since we know it's isosceles, we already mentioned that we get, when we do this, we get an A here. Excuse me, a side here. This gives us a side. Now the other thing we had is we said that this is the median. We got the median here, A to M, and it goes to the midpoint. So what we're going to do is, talk about AM is a median. That was given to us. And then we can use that information to say M is the midpoint, which is the definition of a median. And then we can say that information lets us tell us that CM is congruent to BM. Which is the definition of the midpoint. And that allows us to get another S. So we either need another A or we need another S. And the only problem is, the temptation is to say this is a right angle here or here, but it's not. We don't know for sure. So what we're going to say is, let's use this right here. It's shared by itself. Well, for sure we know that's true, so let's use what's most certain, not try to guess. And we'll say AM is congruent to AM. reflexive property. And that gives us our third S. So we can then say triangle AMC is congruent to triangle AMB by side, side, side. And then we can say angle C, which is what we're trying to do, is congruent to angle B by CPCTC. In a sense, we've proven the base angles theorem, that if the triangle is isosceles, then the opposite angles from those two congruent sides are going to be congruent as well.